So before I start, I just do a few quick checks. The 1.5 volt battery is 1.5. The 9 volt battery is a little less. It's only about 8.5. And I start off also with a simple circuit just to see how everything's going. So that's reading at 1.5, which is good. And the current is over there. It's on the 500 milliamps. So reading it over there, it reads at about 110. So that's 0.11 amps. So the circuit's set up so the ammeter must be in series, so it's always in the same line as all the loads, so that you know exactly what the current is throughout it. And the voltometer is set up in parallel. It meets across the loads, across everything, so you know what the voltage for the whole circuit is. So the first one we're doing is series. So when you set them up in series, what it does, it's additive. So if you add two 1.5 volts together, you see it reads 3 volts. What happens when you put it in parallel, you can see that the voltage is still the same and the current is also the same. So what actually happens is you're just increasing the size of the battery. So this is just, these batteries are metals, reactive metals, so it's chemical potential energy. And when you join up the circuit, then the chemical reaction can take place and the chemicals react, and those electrons are put in movement through those circuits and turned in from chemical potential energy to electrical kinetic energy. And so basically, if you're putting these in parallel, you're just going to have a battery that is going to last longer. This basically, it works as just one bigger battery, and so it's going to last longer. Going to give you the exactly the same voltage and amps. So just putting one in reverse, so I had to swap all these around so I didn't have to re-rig the entire circuit. So the easier thing to do was just to swap the two 1.5s around. And you can see that I'm putting the 9 volt battery in reverse to the two 1.5s. So I would expect 9 minus 3 to give me 6 volts. It's actually a little bit less than that still. It's only 4.5. And so the voltage is increased, so therefore the current is increased. We'll do that later with Ohm's law. But you can see that it does actually still work as long as one side is more powerful than the other. As long as they're not equal and opposite, you will still get a net voltage left or right. And in this case, it's 4.5 volts and 0.2 amps.